Hello and welcome to this special episode of the AI Show. So excited to be here. My name is Seth Juarez. Usually our regularly scheduled program is every Monday at 8:30 Pacific. It's early in the Pacific time zone, but we want to catch as many people as we can across the United States and Europe. We should do one in the middle of the night for folks in Asia. That would be fantastic. Speaking of Asia, if you are in South Korea, I will be in South Korea next week for the AI tour. I'm going to be talking all about how to build your own LLM applications. Pretty excited about that. All right, so let's get started. Let me talk about a little bit about what's going on today, and then we'll get moving along. If you don't know about the AI Show, again, we host a little show every week, Monday at 8:30, but this Thursday at 8:30. So you're probably thinking, you're a fibber. All right, today on the AI Show, number one, Phi-3 with Sebastian. So this is a cool little model. And that's all we're going to talk about today because I think it's important enough to talk about that. Usually our show is, we have a couple of things. And I may do like a number 0, right? Some news of stuff you should look out for in the future. Speaking of things to look out for the future, like I was saying, next week in South Korea, I'll be there to talk about all things AI, LLMs, etc. Come say hi to me if you live in South Korea. It might be the middle of the night there, so maybe not. The other thing that I want to let you know about is a lot of this stuff that we're talking about today and more is going to be happening at Microsoft Build. You can register now, actually. It's May 21st to the 23rd. I will be there. I think I have a talk. They're going to let me talk about stuff. Pretty excited about that. And so that's what we got going on in May. And then after that, it's summertime. I don't know what things are going to happen in the summer, but I'm just excited for the next couple of weeks where we have a lot of news and a lot of AI goodness coming out of Microsoft. All right, I think that's it. Oh, and then the other thing I want to tell you is if you're new to the show, so there's like a couple of things that we do. So the live show is like live, but then in the middle of our live show, we do like the official cuts of stuff. And so I'll bring Sebastian on, we'll chat, and then we'll get into the actual meat of the show, and I lift that show out, and then that becomes more like durable. It's what pays the bills, so to speak. And so you'll see Sebastian and I have a little chat, and then afterwards we'll be like, okay, it'll feel really official. So Sebastian, you ready? Thumbs up. How you doing, my friend?
Hi, Sas. I'm doing great, thanks.
Mm, okay, dude, those are pretty cool news you had yesterday.
Yes, absolutely.
Was
Yeah,
it yesterday or was it Tuesday? It was Tuesday.
it was Tuesday, but it's all blending together right now.
Oh, I see. Yeah, it's pretty cool. I know I know that like when these models first came out, and this isn't part of the show, but I thought you didn't. I just have a chat before. When
Yeah,
these models first came out, my biggest concern was literally like, wow, can everyone use these things? They feel a little big. And so this is kind of exciting stuff, exciting territory for me.
yeah, absolutely. I think more people are gonna be able to use it now.
All right, well, let's get into the official show then.
Yeah,
Let me get stuff ready. Okay, here we go. All right, you ready?
yes, I am.
You're not going to want to miss this episode of the AI show where we talk all about the Phi-3 model with my friend Sebastian. Make sure you tune in. Hello and welcome to this episode of the AI Show. Where we're talking all about the Phi-3 model. My friend Sebastian. Sebastian, how you doing, my friend?
Hi, Sas. I'm doing great, thanks.
Fantastic. So, for those who don't know who you are, tell us who you are and what you do.
Yes, so I'm Sebastian Bivek. I'm a VP of Gen AI research at Microsoft. I have been at Microsoft now for 10 years already. I used to work more on the theoretical side of machine learning, but then with all of the really exciting advances in AI and large language models, I shifted my research to that recently, in fact, about a year ago, and we started to build those small language models back then.
And this is exciting. I am a machine learning guy through and through. I love machine learning, and the fact that these models are doing this amazing stuff with some tweaks, like for the Transformers changed everything. Transformers, right?
Yeah.
So just for those that don't may not know, what is an SLM, and how would you compare those to an LLM?
Sure. Yeah, so maybe let me backtrack for a second and go back to a year ago when we started this project of building the family of Phi models. So at that time, I had just finished a project that some of your listeners might know, the Sparks of AGI paper, where we studied in depth GPT-4, what it can do, what it cannot do also. And for me, GPT-4 was really the realization that if you put a lot of compute, a lot of data, and you build a really, really large model, then something like intelligence emerges. Something that at least displays the behavior of a reasoning engine. And for me, as a scientist, the question became what exactly was needed in this process for intelligence to emerge? What are the minimal ingredients for those models to exhibit reasoning? And for me, I was really excited by this question because I was always envious of other scientific fields. Like, in physics, they get to ask about what is the origin of the universe? What are the minimal ingredients, that makes reality possible? In biology, they get to ask what is the origin of life? What do you need for life to emerge? And so on. And now suddenly I feel like with the GPT models, I got to ask just a question as big as those questions. What are the minimal ingredients for intelligence? And so this points you immediately in the direction of trying to build a small language model, a language model which has far fewer parameters, degrees of freedom than the big ones. So this is a scientific quest that I embarked on a year ago. Now, of course, this is a scientific aspect, but it actually has a lot of implications from a technological perspective. Because if you can reproduce or if you can create reasoning engines that are very small, then this becomes very cost efficient and it opens up all kinds of new applications.
I mean, this is so cool. Between you and me and the wall, the first algorithm I ever wrote was like in MATLAB, and it was k-means. And I
Yeah.
remember like the thing doing reasoning, and it was just like super cool. And so I kind of felt that again when you were talking about like because the GPT series of models are huge, right? But
Yes.
what are the minimal ingredients to make these things still do the reasoning that we need to do? Is an excellent question. And so, what are some things that you found? Because I think you found some answers to those questions.
Yes.
What does reasoning mean? And then what smallness could you get to make it do what it needs?
Yeah. So let me not answer what reasoning means, because
Yeah.
that would get us into a whole different direction. It's a very complicated question. Nobody really knows, but we all have a feeling for what it could mean. So
Yeah.
let's just go with that feeling for now. But what we discovered is through this work on the Phi series of model is that basically you can actually make them a lot smaller. So I can, walk you through the entire history, but let me give you the punchline just now, which is a couple of days ago, we came out with Phi-3, so the third, in this series of model. And Phi-3, if I have to put it in just one sentence, it's a model that is small enough to run locally on your phone. It doesn't really need to be in the cloud. It's not a big model. It's small enough. It's like 2 gigabytes if you had to download it on your phone. Yet its capabilities are very close to the capabilities of GPT 3.5. So the ChatGPT, the free tier ChatGPT. Or, other open source models that people know and love, like Mixtral, the mixture of expert of Mistral 8x7b. So that's really the headline.
And that's really cool, because I mean that gets to like if there's things that you can do in GPT 3.5 Turbo, that level of reasoning you can mostly do in Phi-3 as well.
That's exactly right.
Well, that answers the reasoning question.
Yes, exactly.
Comparably. So now this is the part that's super interesting to me, and hopefully you have some time. What did you do so that it could be smaller and yet still work as well? And I guess I'm asking, like, can you tell us about how it was trained?
Yes. I won't give you all the details,
Right.
but I can tell you a little bit. So maybe it's very simple. So we did several innovations, but let's start with one very basic one, which is we did a 2 phases training. So, many people out there who train large language models, they know about pre-training and that post-training. But what we did is that we also divided the pre-training phase into 2 sub-phases. So we have phase 1 of pre-training and phase 2 of pre-training. Phase 1, you can really think about it as we're trying to teach the model just to learn English, basically, just to learn language. And in this phase where we're trying to teach it just to learn language, we do kind of the usual thing, meaning we feed it, open web data, except that it's not just open web data like everything you can get your hands on. No. We actually filter it very, very heavily to keep, just the things that is going to be enough to teach it the basics of English. Okay, because by the way, Phi-3, at least a small version, is English only just because of capacity reasons. So that's phase 1. And then in phase 2, it's basically as if the model is now going to college. It's like now, it has learned all the basics, and now it has to learn slightly more sophisticated, more advanced material. And for this more advanced material, what we did, and this is really the key difference, is that we created a lot of synthetic data. And that's what makes the biggest difference between Phi-3 and all of the other models out there, is that in this second phase of training, where we teach it advanced concept, they are all taught through synthetic data. Now, people are very, very confused out there about synthetic data. I hear a lot of worry. Oh, you're going to use an LLM to create data to train another LLM, and you keep doing this loop. Aren't you going to eat your own tail? And eventually things are going to diverge, and the model is going to be useless. Well, from my perspective, nothing could be further from the truth. And the reason is this is rooted in a deep misunderstanding of what is meant by synthetic data. What is meant by synthetic data is not that you go out there, you go to ChatGPT and you say, hey, ChatGPT, can you write for me billions of tokens of training data to train a language model? Like if you do that, you just press the button. I encourage you to do the experiment, actually. You will be very disappointed with what you see. Instead, what you have to do is you really have to pick concepts one by one, and you have to think very deeply about how you would prompt an LLM in order to write data that would teach this concept. And then that's not enough, because you have to root things into reality. So you have to find some seed of reality that you're going to feed into your pipeline to produce the synthetic data. And that's still not enough, because you also have to verify that the model is doing a good job and is producing reliable and correct data. And if it's not, then you have to go back and you revisit either the prompt that you use or the seed that you use. So what I'm trying to say is that it's a lot of work just to create a single data set for a single concept. And you have to do this hundreds of times in order to create a big data set that you can use to train a Phi model.
Like my intuition as a data science guy is like you've basically just said that we could make the model smaller if the quality of the data is better
Yes.
and you do it in two separate stages. Am I getting this right?
Yeah, absolutely, absolutely. So the essence of all of this, the key insight between everything is that quality of data is everything. And of course, this is not groundbreaking. I mean, in machine learning, we've been talking about this forever.
Yeah.
But now the whole question is, what does quality mean? And this is really, really important for the listeners to understand. What is high quality data, or what is good data, will be different for a 3B model, for a 7B model, for a 14B model, for a 100B model. So depending on the size of the model that you're using, you will be encouraged to craft data that looks different. Just like, I mean, I don't necessarily love analogies with human beings, but this one is maybe a good one. It's like if you want to teach a 5-year-old or a 15-year-old, you're not going to use the same examples. You're going to come up with something very, very different. And it's the same thing with language models.
I mean, this is cool because like this all makes intuitive sense to me. Effectively, what you're saying is you get a base layer of language. And by the way, for those that don't know, I studied computational linguistics and how to do translation and language models and how we. That's been something that's been studied forever, right? With n-grams and whatever. And so
Absolutely.
it makes sense to me that you get a base knowledge and then you basically train concepts over it. So does
Yes.
that mean that the Phi-3 models are concept specific? Or
Okay.
concept generic, or is there even such a concept?
Great question. Great question. So what we've done is I really think about it as phase one is this first base layer of just being able to read, just teaching it to read. But then the second phase is still a base layer, but it's a base layer of more advanced concept. And then there is kind of the magic of deep learning that would make it that, okay, you're teaching it all these individual concepts, but actually the model is learning the connections between them. It's kind of drawing the bridges between all of these concepts. So after phase two, the model is absolutely not like a fine-tuned model. It's a model that has a very broad and general, understanding of the world. And then on top of it, if you want to, and that's one of the great benefits of small model.
Yeah.
On top of it, if you want to fine-tune it, well, it's very inexpensive. It's a small model. You can do it very, very quickly.
Yeah, and that's it. That's the part that I was going to ask next. Because like if it's a small model, that means that fine tuning it for very specific use cases is actually in reach for just normal folks like me, right?
Absolutely. And here I want to add something, which is sometimes people misunderstand also this point. Even if you have a narrow, very specific application and you have data for this specific application, just training a model on this data might not be enough. Why is that? It's because your data is making all kinds of assumptions about the world, about human beings that is not explained in this data. This is the issue of common sense reasoning. Common sense reasoning is everywhere. Any data produced by human beings, the only way to make sense of it is to have common sense reasoning. So what we did with the Phi series of model is that we have built for you a base layer which has common sense reasoning, which has logical reasoning, which has all of these general abilities that are needed to make sense of data produced by humans. So now you can take this base, take the data that you have for a specific vertical, and go and fine tune it. And you're right, because the model is small, it means you need less data. It means you can do it very fast, very inexpensively. It's really a game changer, I think.
I mean, and that's really cool. And now here's a question that I get a lot. It's easy for these models to diverge unless you regularize in specific ways. For those
Yeah.
that are fine tuning, any tips, for example, to make these things? Because I've heard this is a saying. It's easier to make these things less smart than it is to make them more smart. So tips on that.
Yeah, absolutely. So the nice thing is, with the Phi-3 family, we've come out with all kinds of goodies for everybody, and I think we're going to talk about it.
Yep.
But including on the Azure AI Studio, we have fine-tuning recipes on there. So people can just go in there. In fact, it's very automatic. You can provide your data. We will fine-tune it for you. It's, I think, we made it very easy.
This is great. So now I want to get into some other things because we've talked a lot about size, but I'd like to get more specific on like what do these things look like in terms of size, and then let's dig into some of the benchmarks of like, okay, because you said it's comparable, but how comparable is it to the GPT 3.5 Turbo series, for example?
Yeah, absolutely. So the one that we released a couple of days ago, it's Phi-3 Mini. It's the smallest in the family, which already is, comparable or attaining the level of mixture of expert 8x7B. It has only 3.8 billion parameters. So 3.8 billion parameters, again, it means that when you quantize it, it's like 2 gigabytes. You can inference this on your phone. You can literally having on any modern phone, this is going to run. So that's the size that we're talking about. If you remember GPT-3, what was it, 4 years ago, this was 175 billion parameters, right? I mean, the Llama 3 models, they have an 8 billion and a 70 billion. Here we're talking about much smaller, 3.8 billion. So that's the first one that we released, and we're going to talk about the benchmark numbers and all of that. Then we have we did some initial scaling experiments because, of course, we're still interested to understand, scaling really helps. If you make the model bigger, will you get better reasoning? Will you get better memorization? All of that. So we did 2 experiments, a 7 billion parameters model and a 14 billion parameters model. We call them Phi-3 small and Phi-3 medium. Okay. And what we're seeing is very nice scaling laws. And this is maybe something we can talk about also is, how does the scaling laws for Phi compare to the scaling laws for other models, like the Llama models? This is an interesting question. But these are the size, 3.8B, 7B, and 14B. The 7B and 14B will be released in a couple of weeks.
So they're 2 gigabytes is tiny. Like you could put it in your web app kind of thing and load it and have it in memory. Obviously, you'd have to have at least 2 gigabytes of memory, but that's not that's an inexpensive thing. So the other thing is the benchmarks. I want to ask you about that.
Yes.
And then like you brought up the point of the scaling because there was this Moore's laws of CPU that plateaued.
Sure. Yeah.
We're kind of seeing some of that with large language models as well. I'd love to know what that hockey stick looks like for the size.
Yeah, sounds good. So those 2 topics are related. So let me talk just a little bit about the benchmark and then the scaling laws. So the benchmark, one benchmark that everybody cares about right now is MMLU, which is this kind of science-based Q&A. And Google, when they come out with their Gemini models, they made a big deal out of the MMLU numbers and so on and so forth. The MMLU numbers that we reach with Phi-3 Mini is 69%. So 69%, this puts you, this is what Mixtral gets, okay, with 45 billion parameters. So with 10x the number of parameters, like 45 billion parameters, you don't put it in your web app.
No.
Like this is a very, very serious thing to deploy. What I'm telling you is that we have packed in these 2 gigabytes just as much information as there is in these 45 billion parameters. So that's pretty significant,
that's cool.
I think. Then you can go to other benchmarks like, Art Challenge or Art Easy, like all of these benchmarks, we are reaching in the 90+% accuracy. So, once you get in the 90+% accuracy, it basically means you've solved that task. You've solved that benchmark.
Yeah.
First of all, because you have to remember, those benchmarks are not perfect. It's also human beings who made them. So there is a couple of percent of error. So probably you cannot reach above 95%.
No.
The last 5% are kind of erroneous anyway. So once you reach the 90+%, you kind of have solved the benchmark. So these are on these common sense reasoning benchmark, I would say they are just solved by Phi-3 Mini. But then you can go into more difficult reasoning benchmarks like GSM-8K or Human Eval. So GSM-8K, this is a grade school mathematics benchmark. Human Eval is a coding benchmark, both of them by OpenAI. And they test, more advanced reasoning capabilities. There, Phi-3 Mini, so for grade school mathematics, it really excels. It's at 80+%. So not sold, but 80+%, which is very, very high. I think it's as high as Llama 3 70B, basically.
Yeah, that's
on
pretty good.
mathematics.
For those that are listening, by the way, like if a data scientist gets 100% accuracy on a thing, we always know something's very wrong. And
Yeah,
so just you need to understand that when we say 90%, we're like, wow, that's really good.
yeah.
To us, that's an A. 100% means something's very wrong.
Absolutely, absolutely, 100%. And things like human eval, the coding benchmark, reaching like 50% is already very, very hard. It means, imagine like I ask you a random coding question. If you can get it right in just a few minutes with 50% accuracy, that's pretty good actually. That's pretty
It's
significant.
better than me, just normal.
Yes, absolutely, better than me too actually.
Yeah.
So this is the picture roughly on benchmarks for the Phi-3 Mini. But then what is interesting is to see how those benchmark evolves as you scale up the model. When you go to 7B, when you go to 14B. And again, you can do the same experiment with the Llama models. You can see the Llama models, from 8B to 70B, or you can look at the Llama 2, from 7B to 30B to 70B. How do those benchmark evolve? So let's do this experiment.
Okay.
And this is, it's called the scaling laws, because what people have observed is that if you do this right, then there is kind of a linear, like a very predictable increase in the benchmark. That's why everybody is going after bigger models, because kind of predictably, you know that if you build a bigger model, you're going to get a better benchmark number. So let's look at MMLU, this science-based, benchmark that everybody is focused on. And let's look at the size of the model versus your MMLU accuracy. So if you look at the Llama 2 family of models, you will see a linear trend in terms of the increase, which is the scaling law, predictable improvement, But then here is a question you can ask. What is the slope of this line?
Yes.
If the slope is larger, then it means you're increasing faster per, parameters that you add. And literally, we have this plot in our technical report. You can literally see the line for Llama versus the line for Phi. And Phi just has better scaling laws. And the reason is because we work so hard on crafting data, which is exactly the right level of difficulty for a given size, for a given model size. So it makes sense that we are kind of changing the scaling laws. And it points again to the fact that these are not laws. Just like Moore's law is not a law. These are empirical observation. And nothing tells you that you have to keep going on that line. You can break and have a line that goes much faster.
Yeah, and I think the key insight for me that is kind of like the smartest things that I ever hear are like intuitive in hindsight. If the quality of the data is good and you continue like to do a two-phase pass on like basic foundations plus reasoning,
Yeah.
if the quality of that data is good and it increases, then the size of the model invariably has to increase as well a little bit with a
A
little bit
little
less.
bit, yes. And this is exactly the question. The question that I'm fascinated by is how do you in tandem increase the complexity of the data and the complexity of the model? Those things have to go together. It's not like you can try to jump and just increase the scale of the model. And OpenAI is pushing very, very hard on that front, and they are doing a fantastic job. And scientifically, it's incredibly interesting, to see how the frontier models, how far they can go.
Right.
What we're doing is a different direction, and both I think are very, very valuable.
Yeah, absolutely. Like I as a programmer, right? We make it work, then we make it right, then we make it fast, and it
Yes.
feels like we're kind of getting to that space with LLMs and SLMs. And while now we're trying to discover can we make these things smaller and yet still get the quality that we need.
Yes, absolutely.
So let's talk about use cases for a second, because I'm sure there's a ton of use cases for this stuff. But what are some things that you're seeing people do with SLMs, and how can people take advantage of them?
Yeah, so I think there are like many different possible applications. And also I want to say, to your listeners, like I shouldn't be the one describing the use cases. I'm hoping everybody will come up with their own use cases. I think really it's hard to overstate the significance of what it means to have a GPT 3.5 level model that is small enough to be on your phone. I mean, who knows what he's going to be able to create with this. But let me just give some ideas. So the way I see it is that there are two types of main use cases. One is when you are in resource constrained environment where it's, maybe you don't have internet connectivity, or maybe you really want, for privacy reason, to run locally. So these resource constrained scenarios are one bucket. The other one is when you're making millions of calls to your model, millions, billions of calls. Like every time we have lots of decisions to make at scale. So these are two completely different scenarios. So let me start with the resource constraint scenario. I could imagine a Phi-3 model to be deployed in an airplane. And maybe, like the airplane doesn't have internet connectivity, but you have this kind of intelligence on board that can help you to do all kinds of things that can maybe, entertain the passengers. I don't know, but this is just one example.
Yes.
Or, you're going hiking. I love to go hiking. You're in the mountains. You don't have internet connectivity, but you have these things that knows many, many things. You can ask it, hey, what is this flower or whatever, Once, especially if you enable vision, which is something that we plan to do very soon. So this is one set of application. For the at scale application, I mean, again, you can think of millions of examples. One that I like is, on Copilot, if you go on Bing and you want to chat with GPT-4, you have these different modes, right? Balance, precise, creative. Now, what you could do is you could also do a routing system where when a user writes a query, some other systems decide whether to route it to the balance mode, to the creative mode, or to the precise mode. This routing question, it is an intelligence-based decision. You have to tell, given the query, what is the level of complexity of the intelligence that has to reply to it. So this routing, you could use Phi-3 to do the routing because you want to apply it to every single query. So things like that.
Yeah, and that's like when I first heard about the Phi-3 models, I was like, wow, I could save calls to larger models just to say this is a support ticket versus this is a sales question, right? And like Phi-3 models could do that easily. It could probably categorize like 5 things that, well, this is that. And just the notion of intelligent routing based upon text is coming in is so useful in almost all the use cases I've ever seen. But
Exactly.
the thing that I liked at what you said is that you weren't like, oh, in healthcare, blah, or in blah, blah, blah. It was more like in places where you don't have the internet.
Yeah.
Or where you have to run millions of calls at once. Like, to me, that doesn't corral the use case. There's tons of use cases for that particularly. Okay, so I feel like I want to look at some stuff. Do you have stuff to show us?
Yeah, sure. I mean, if you want, we can do some experiment together, like just try the model and see what it says.
Let's do it. So if you share your screen right there in the middle.
Yeah. Let me do that.
All right, here we go.
Yeah. So what you're seeing here right now, this is our internal playground. And what I'm going to do is that I'm just going to ask some question to Phi-3 Mini, and we'll see what it says. So let me start with one simple question. Why is it surprising that the entropy of a black hole is proportional to its surface area? So, this is a famous discovery of Hawking. Let's see what Phi-3 says. And of course, it's surprising because, so first of all, you see the speed of response.
Yeah.
This is, not like
fast.
Yes, it is fast. It's not like, the big models. And, why is it surprising that the entropy of a black hole is proportional to its surface area? It's because usually it's proportional to the volume.
Yeah.
But, for black hole, it's complicated because of the holographic principle, blah, blah, blah. So the fact that the entropy of a black hole is proportional to its surface area rather than volume is indeed surprising and counterintuitive. So this relationship is known as the Bekenstein-Hawking formula, blah, blah, blah. And here it starts to, explain to you that, okay, here, you see this relationship led to the holographic principle, blah, blah, blah. So it exactly explains, what you want. Let me try another one. So this is one of my favorite one. Draw a unicorn in TXZ. So for the listeners who maybe don't necessarily know about what is TXZ, so TXZ, this is this programming language to draw mathematical figures. So we use this when we write, research papers in LaTeX. And it's a huge pain to draw in TXZ. I mean, I have wasted lots of hours during my PhD thesis drawing figures in TXZ. And drawing a unicorn in TXZ is a very, very hard task. Okay, so let's see if Phi-3 Mini can do it. Okay, here is a basic example of how to draw a unicorn, and boom, it gives you the code to draw it, and you could just compile this thing, and it will give you a nice little unicorn, which is highly non-trivial. And again, you see the speed at which this thing is responding, which is, by the way, another type of use cases that we didn't mention is anything where latency is really, really important. This is perfect. This replies to you instantaneously. Maybe let me try a last one. Write chocolate cookie recipe in the tone of a depressed person. Okay, so you see here, the thing is, again, what I'm trying to do is that I'm trying to ask questions that are not out there on the internet, that are just, to test that it's not memorization, but really kind of some real reasoning, and to see also some amount of creativity. So let's see what it says. Okay, so here is, but let's just say that life seems to be one giant cookie jar, and every time I reach in, it's just a different batch of disappointment.
Oh, wow. It is depressed.
Yeah, it's okay. So put some sugar, not quite as sweet as life seems, a cup of brown sugar, a bit like the weight of the world,
Oh my gosh.
Yes, it is pretty harsh with itself. Okay. And there you have your very own batch of depressed chocolate cookies. Enjoy them at your own risk. And remember that even in the smallest things, there is a sliver of.
Oh, wow. It ended with a nice
It ended with a nice note. Yeah,
so
exactly.
What model is this one, by the way?
Right. So this is the smallest one. This is Phi-3 Mini, 3.8 billion parameters. This is the one that runs on your phone.
This is the smallest model?
This is the smallest one. That's right. Yes.
I feel like there needs to be like a mic drop moment. That's really, really cool. So I know we've talked a lot about this stuff. Where can people go and get these things?
Yeah. So we've really tried to put it in all the places that people, love to get their models from. So it's on Hugging Face, it's on Azure AI Studio. You can get it on Olama, and deploy it on your phone. So all of those places, you can get it right now. And again, at this moment, you can get the models that I just showed you, the smallest one, and very soon, in a couple of weeks, the two bigger one, which are significantly more intelligent.
Yeah, and so I want to show the link if you're looking at it. This is the Hugging Face version of it. It looks like it's inside of the AI Studio model catalog. You can see that here, and I think you could even try it out in the model catalog if you have an account, which is really nice. And there's the try it out. So
yeah, I would just say to people, be careful when you try it in there to make sure that the max token length is not set to the preset 128, because Phi-3 Mini likes to have very long responses. So you need to have a max token of at least 1K.
That is amazing. Well, my friend, thank you so much for chatting with us. Is there like a blog post somewhere that people can take a look at all this stuff?
Absolutely. So there is a Microsoft blog post, and you can also find a technical paper on the archive. It's called Phi-3 Technical Report. And there you will see all of the benchmark. You will see the scaling laws, the new scaling laws that I told you about, and more details.
Well, this has been super impressive. Thank you so much for being with us, my friend.
Thanks, S.
And thank you so much for watching. We're learning all about Phi-3, a brand new small language model that Microsoft put out. Thank you so much for watching, and hopefully we'll see you next time. Take care. All right, that was the official show. So now let's see if I think there's a ton of questions here. Are you okay answering some questions?
Sure. Yeah, definitely.
All right. So let me make this a little bit bigger so I can see, because I am just getting older, Sebastian. Believe it or not, I'm not this youthful. And all right. So here, Yvonne is here. She's saying amazing topic today. She's in South America. She's awesome. Let me go. Here's a question: how complex do the textbooks need to be?
Great question. Not an easy question.
I know. We don't know, right?
Yeah, not an easy question. So this to me is a frontier research question. Exactly the question you're asking is, how complex needs to be the data if you're teaching a 1 billion parameter model? How complex is it if you're teaching a 2 billion parameters model, a 3 billion parameters model? I believe the complexity will need to depend. We have some gut feeling about it and we implemented it in the data that we created. But I think doing this a little bit more systematically is a fantastic research direction.
Yeah, I did research too, but I dropped out. My advisor went to a different college, so I'm a college dropout, Sebastian. I'm so sorry that I.
Yeah, as I told you, I know a few college dropouts who did pretty well.
Okay, all right. Here's a James also. How would you compare the methods you use here and the methods used in the 1-bit LLM? I don't know what a 1-bit LLM is.
Yeah.
Maybe you know.
So so the 1-bit LLM, it's different because here we're talking about the pre-training phase where we're first training the model. The 1-bit LLM is going to be at the end. It's a post-hoc process where you quantize the model and make it, much smaller in terms of the complexity. But in principle, both of those things can happen at the same time. You don't need to separate the two. So can you do a 1-bit LLM version of Phi-3? Maybe.
I see. So you're saying that the quantization can be a post facto thing after training, and that totally makes sense because that's how you make these things. Instead of a double wide, you make it a float or whatever, and it just
Exactly.
half the model size on that. Here's a question from the Bipin. At what point does the angle of the slope go down? Because extrapolating what you just said, larger the model, better. So how do you draw the line between size and accuracy? And that's interesting. Like, I'm sure these things reach a plateau. It's not linear. It's more.
Yeah. So excellent question. So what you should do, first of all, this is a log plot. So you don't plot literally the accuracy. You actually plot the log of the loss. So you really plot the error, and it's a line, more like a line going down.
Yeah.
And so what there is a plateau at 0 in that.
Yes.
So the plateau at 0 will just correspond to minus infinity in the log. So you can keep going down forever, but it's just when you go down very, very far in terms of your accuracy, it just means you improve from 99.9% to 99.99. And for this, you need to go very, very far. So it's a log plot. That's really the important thing.
And that's important too, because there is a training trade-off, because these things cost money to train.
Of course.
And when you it turns out that it's harder, as you get closer to 0. And then the question is, do you really want to go to 0 with these applications?
Yes.
I don't know. I mean, it's a good question.
That's exactly the right question. Yeah.
Yeah. Okay. So here is another question from Brent. What is the estimated expected cost of Phi-3 models? How is it different than the LLMs that are available?
Yeah. So it is really a dramatic difference. And I can't answer simply your question because it depends on where you're going to deploy it.
Correct.
If you deploy it on Azure, if you deploy it by yourself on your laptop, if you deploy it on your phone. But let me just say, the point is, Phi-3 Mini can run anywhere. It can even run on the CPU on your laptop. It really needs very, very little, if anything. So that's the key point. It's almost like you don't even think of it in terms of cost anymore. It's just that it can be everywhere.
And I love the idea that it's so small, because then you can use a combination of models, bigger frontier models, Phi-3, other models that have vision burned into them, to really get a combination of models that are doing some interesting work for you.
Absolutely. And then there will be the question of orchestration. How do you navigate between all of those different models?
Yeah, and here, I know that's another thing, because I mean, orchestrating between the things, you can have Phi-3 make decisions to do orchestra, because it's very good. Like my gut, and you tell me what you think, and we'll get to Ratish in a second. My gut is telling me that I would use Phi-3 to reduce text into small decisions, and it would be very good at that.
Absolutely, it is very good at that.
Yeah, and so everything, for routing is an excellent example, or for deciding whether to continue an orchestration loop, for example, that goes to other LLMs. I mean, I think it's fantastic. Here's Ratish saying, incredible to see the type of response having a speed with which the SLM is responding with just 3 billion parameters. I mean, yeah, it's no joke. And I thought GPT 3.5 Turbo was getting fast, right? Because it went from 7 to 5 to 2, now 2, and then sub-second responses. But this is instant. It feels like.
Yeah, it's almost scarily fast.
Yeah, yeah. Here's Joaquin saying the SLM sits on a device with knowledge, doctor rule environment, doctor.
Absolutely.
It's really cool, and you can fine tune some information into that to make it even more.
100%.
All
Yeah,
right,
this
my
is a
friend.
great application.
Yeah. Any final things that you want to add before we sign off for today?
Yeah, I guess just the fact that with this Phi series of model, we're discovering kind of a new regime of scaling laws. I'm kind of really excited to see how far we can go now and take it to the next level. So that's what we're gonna plan to do in the next couple of months.
This is awesome, and like I said, because it's just like any other LLM but smaller. You can do all the other kinds of evaluations with GPT Star Evaluate. You can do everything you can do with all the other ones as well. Because someone asked about hallucinations or accuracy or whatever, you can use all the other testing methods that you have for those ones for these ones as well.
100%.
Well, thank you so much, bud.
Thank you.
We'll talk soon.
Bye bye.
That was fantastic. I'll start with the. I'll get the walk-off music going here because we're kind of out of time. This has been an amazing show. Sebastian's really nice. A couple of things for those that are watching, and this is your first time. Our YouTube channel is over at youtube.com/The AI Show Live. That's the AI Show. We have weekly shows every Monday at 8:30 with wonderful guests like Sebastian, among other people. And our goal really is to inform you on the latest and greatest stuff in AI in an approachable manner. If you don't think you know AI, I am here to tell you you can use it and you can put in your applications today. These Phi-3 announcements have been absolutely amazing to me. It's pretty cool to be able to be in the space when it's just all this stuff is happening. Next time on the AI show on Monday, I'm going to be in South Korea, so we're going to have a little bit of some reminders of some cool content that we've had before. I'm going to put together a little package for everybody. That's Monday, April 19th at 8:30 a.m. Pacific. And if there's a topic that you'd like us to cover, I'm happy to do that. We have about 4 weeks until Microsoft Build. We're announcing some pretty cool stuff that we can't talk about, obviously, right now. But we're gonna put together a series of shows to get you into the latest and greatest, all things AI. As always, it's a privilege and a pleasure to be with every one of you. I know you have stuff you can do with your time, and the fact you spend it with us, I'm really grateful. Thank you so much for watching. And again, this is the AI Show on YouTube, amongst other places you're probably watching. Thank you so much for watching, and hopefully we'll see you next time. Take care.